Hello, Precalculus student. This video is for chapter 6.3, Inverse Trig Function, part 3. And in this section, we are going to talk about composition of inverse trig functions and the original trig functions. So because they are inverse of each other for sine and sine inverse, so in general, if you have a sine inverse in the beginning, meaning in the inside as an inside function, and then you do a sine function after that, then it is equal to x because they cancel. Because if x is in the domain of the sine inverse, right? So x has to be between 0 and between -1 and 1. So it is also in general okay for cosine and tangent. But if you have sine inside, but sine inverse outside, that means you do x is an angle, and you go through sine to get a sine x between 1 and -1, and then do a sine inverse. You may not be able to cancel them and equal to x, because the domain of sine can be any angles from -infinity to infinity, whereas the sine inverse function has a restricted domain for angles that is only in -π/2 to π/2. So you may not just cancel the sine inverse and sine to equal to x. Okay, so you would have to actually evaluate them. You evaluate sine x and then you evaluate sine inverse. So remember, if the inverse is inside, in general you can cancel if x is between 1 and -1. But and then for everything in tangent. But if it is inverse, the sine inverse is outside, you have to evaluate if x is not in the restricted domain. So if I do sine inverse inside, then I can just cancel 1/2 because 1/2 is between 1 and -1. But if I do sine inverse sine of 5π/6, I cannot just cancel it by saying that it's 5π/6, because sine inverse sine inverse does not give an angle for 5π/6. The restricted domain for sine was -π/2 to π/2, and 5π/6 is not in this domain. So instead of having it equal to 5π/6, we have to calculate it. So how do we calculate? We just when we calculate a composite function, we would do the inside first, right? What is sine 5π/6? In the unit circle, 5π/6 is right here. So sine is the y value is equal to 1/2. So we would say that is sine inverse 1/2. So this is 1/2 from the unit circle. What is sine inverse 1/2? Sine inverse 1/2 would be what is the angle? So looking at this, only these two quadrants. So 1/2 of y is here. Y is sine, right? So this corresponds to π/6 only. So that's equal to π/6. Okay, so it is not equal to 5π/6. Okay, so let's do some example of these. So from the outside, it looked like you can cancel them, but you cannot because sine inverse is outside. So let's think about, is π/3 within a restricted domain? Yes, π/3 is in a restricted domain, so we can cancel. So we can just cancel, and that's equal to just π/3. If you don't know, you can actually just do it. What is sine π/3? Sine π/3 is √3/2, right? Sine π/3 is √3/2, and what is √3/2 for the inverse is still π/3. Okay. And what about cosine cosine inverse of cosine -π/3? Can I cancel? I cannot, because the restricted domain of cosine is 0 to pi, and this is outside of the restricted domain. So we'll just do this one by one. So what is cosine -π/3? -π/3 is actually the coterminal with 5π/3. Cosine is 1/2, right? Cosine is 1/2. So that is equal to cosine inverse 1/2. Remember how to evaluate cosine inverse 1/2? We would look at positive for cosine is first and second quadrant. Well, first quadrant for positive, second quadrant for negative cosine. Cosine is x, right? So we were looking at what was it? 1/2. Okay, which one is 1/2 for cosine? Is pi over 3. So it's not negative pi over 3, but pi over 3, right? Although negative pi over 3 would give also 1/2, but our restricted domain is 0 to pi. 0 to pi, because it has to be in 0 to pi. So we give the answer has to be from 0 to pi. For tangent, the answer has to be in negative pi over 2 to pi over 2, right? Our 3 pi over 4, this one is not in it. So we have to calculate it. What is tangent 3 pi over 4? 3 pi over 4 is right here. Tangent is negative 1, right? Root 2 over 2 over negative root 2 over 2 is negative 1. So we would just do one step at a time. So it's tangent inverse of negative 1. And then we evaluate tangent inverse of negative 1 by saying, well, which one has a negative 1 for quadrant 1 and 4? This is the one that we have do before. So it is negative 1 correspond to negative pi over 4, right? In quadrant 4, when we do inverse, we use the negative angle, negative pi over 4. You can see that you can just cancel them if the angle is not in the restricted domain. Another composition of inverse function and a trig function is if you're compositing with a different trig function. That means you are doing a sine of a cosine inverse. Okay, so how do I do this? Do I actually use the calculator to do it? No, if I want to evaluate the exact value, so I do not want to do an angle and then sine it, right? So what we use is we will use right triangle and Pythagorean theorem relations to find. So first is cosine inverse will give an angle, right? Let's just let this be theta. So we say use assume or substitute. Okay, let cosine inverse 2 over 3 equal to theta is an angle, but we are not interested in finding the angle. We are interested in finding sine theta. So because of this, if I cosine both sides, cosine of theta, if I cosine this side outside, and then I cosine inverse, remember, this would always work, right? Equal to theta. I can cancel this. It's 2/3 equal to cosine theta. Okay, so cosine theta equal to 2/3. I can draw a triangle. I don't know what this angle is, but cosine is 2/3. Oh, 2/3. Okay, not this one. Cosine is right? Adjacent over hypotenuse. So draw a right triangle and write the corresponding side. And now I have a missing side that I don't know. So what would this be? So let's say this is b. So b squared plus 2 squared is equal to 3 squared. So b squared would equal to 9 minus 4. b is equal to root 5. So write root 5 here. And now I want to find the exact value of sine theta. Remember, we replace this as theta. We did not solve for it. We just say sine theta equal to, if you read off from the triangle, sine is opposite over hypotenuse would be root 5 over 3, and it is exact value. Exactly. Okay. Do not solve for theta and then do it, but use a right triangle and then the Pythagorean relation to solve the side to write the exact value of sine of cosine inverse 2 over 3. Okay, so another example. I want to do sine of cosine inverse x. Oh, do I have another example? I think this is the only one now. Oh no, yeah, that's another one. Sine of tangent inverse 7 over 4. So again, we just say this must be an angle, theta. So we would say tangent inverse 7 over 4 is equal to theta. And then we did tangent outside. Tangent inverse. Remember this I can cancel. Anytime you have the inverse inside it, this you can always cancel. It is when it is reversed that you can. So, oh, this is tangent. Tangent theta. So tangent theta is equal to 7/4, right? And then we can draw the right triangle. This is theta is 7 TOA/4. And we have c missing, right? So solve for c. C squared equal to 7 squared plus 4 squared. 49 plus 16. 65, right? C squared. So c is square root of 65. Now our goal is to find sine of theta. Sine of theta would be what? Saw 7 over square root of 65. And that's the exact value. Two more composition question. In this case, we have sine, but cosine inverse, but it is x. So we don't know what theta is. So we do the same thing, cosine inverse theta, cosine inverse x equal to theta, and we do cosine both sides. Cosine theta. So this cancel. X is equal to cosine theta. So we can write it as x over 1. Still draw a right triangle. It's not a number, but we can draw a right triangle. Cosine is adjacent over hypotenuse, x over 1. Okay, so this b would equal to b squared plus x squared equal to 1. So b squared equal to 1 minus x squared. Of course, x has to be between 0 and 1, right? So this would work. B was square root of 1 minus x squared. So say 1 minus x squared. And what do I read? I want cosine theta. Sine theta would be, this is theta, opposite over hypotenuse. So square root of 1 minus x squared. Last one, okay, so cosine of arcsine 2x. So arcsine would give an angle. Let's say arcsine 2x equal to theta. If I do sine of arcsine, it would cancel it. Equal to sine theta, right? So this would cancel, that is equal to 2x is equal to sine theta. I still draw a right triangle. This is still theta. Sine of theta equal to 2x. 2x is opposite over hypotenuse, 2x over 1. So what is b then? B squared plus 2x all squared is equal to 1. So b squared is equal to 1 minus 4x squared. 2x times 2x is 4x squared. So b is square root of 1 minus 4x squared. So now, but I want cosine theta. So cosine theta is b over 1, right? b over 1, so that's just b. 1 minus 4x squared. So these two compositions shows up eventually in calculus. So that's why we want to introduce this. Okay, so composition of inverse function. And that's all for 6.3.